All right, Algebra 1, we're doing lesson 56, 57, 58. We're going to go through all the notes today. Whatever we don't cover today, I'm going to finish going over tomorrow. My goal is to go over the notes for these 3 lessons today, to work out some practice problems with you tomorrow, so you have enough to get started tonight on hopefully lesson 56 and 57, because between 56 and 57, that's 17 questions, right? If I can knock out those 17 questions today, then I should be able to knock out the remaining 15 questions tomorrow. Does that make sense? All right. So lesson 56, we're going to talk about identifying, writing, and graphing direct variation. Okay. Direct variation is when one variable is expressed as a constant times another variable. That's what's called direct variation. Our basic equation for this is y equals kx, where k is the constant of variation. Okay? Constant is a non-zero constant, okay, called the constant of variation. It shows a direct variation between x and y. Well, the reason we call this direct variation is because there's something that is opposing to direct variation, which we'll learn about later, and that's called inverse variation. Okay, so just so we understand that this is direct, something else will be different. Okay, so if I'm going to write a note somewhere, and I should be keeping notes, if nothing else, I'm going to say direct variation, right? And I'm going to write y equals kx. Okay, and then I might write k equals constant. What is a constant? Does anybody know? Constant is usually a number that doesn't change. Okay? So for instance, we would use something like this to solve real-world problems. Let's say that y was equal to cost. My constant was $2.19, and x is the number of gallons that I'm going to put in my car. Okay, that is a direct variation question where, let's say my mom and dad gave me 20 bucks, right? The cost of gas is this. How many gallons can I put in my car so that I don't go over my $20? Do we see how a real world problem like that might be useful, right? If I have a set amount, right, I don't want to go over that amount, right? Okay, so we could solve a problem like that, right, and find out how many gallons I could put in my car, right? Or if I knew, like, hey, I forgot how much gas cost, right? I didn't look at the cost. I just know what it cost me after I pumped it, right? And I know how many gallons I put in. Could I find out what the constant was? Yeah, I would be solving for k at that point. So given 2 pieces of information, right? If I know y and x, I can find k. If I know y and k, I can find x. If I know k and x, I can find y, right? If I know what the constant is, right? If I know what the cost of gas per gallon is, and I know how many gallons I put in, can I figure out what my cost is going to be? Yeah, just take, whatever the cost of gas per gallon is, multiply it by the number of gallons I put in a car, and that's going to tell me what my cost is. Now, direct variation isn't always using those exact terms. That's just an example. So we see some representation down here. We have the equation form, y equals kx, where k is a non-zero constant. In a graph, it's going to be a line that always goes through 0, 0. Okay, it doesn't mean that the slope is up 1 over 1, but it does mean that it's always going to start at 0, 0. Okay? Because let's go back to our illustration or our example of going to the gas station, right? At the point where I put 0 gallons in my tank, what is my cost? 0, right? So if my input is 0, then my output is 0. And it will be that way for every single direct variation equation. Because, look, it's k times x equals y. If x is ever 0, right? What is every single number times 0? 0. So if x is 0, then y has to be 0, correct? Okay, so do we understand why the graph is always going to start at 0, 0? Yeah? Okay, because if my input is 0, then my output is 0. In words, we would say that y varies directly with x. If I see a sentence like that where they're talking, they're asking you to set up an equation, and they say y varies directly with x, I know it's a direct variation equation, and I know to write it as such. It's going to look like that. Okay, so if y varies directly with x, we're going to say y equals kx. They might write x is directly proportional to y, in which case this is still my equation. Okay? So that's helpful because they're going to give me word problems, right? And I need to know how to set those up. So if I see it started with words like that, right, we know how to write it the equation. Does this make sense so far? Have I lost anybody? Everybody shakes their head no. Okay. All right, next slide. If we're solving y equals kx for k, it gives a ratio for the constant of variation in a direct variation. So if I have this to start with, and I want to know what k equals, right? Just, let's see, let's do this for a second and drag this down. Let's say I'm starting with this, right? How do I solve for k? Divide by x on both sides. Good. Okay? So divide, and maybe you already saw that, divide both sides by x. So I'm dividing by x, I'm dividing by x on both sides, right? Does anybody know why x cannot be 0? Why can x not be 0? Right, because at that point I'm creating fractions, and can I have 0 as a denominator in a fraction? No. Okay? All right, so after that, right, we get k equals y over x. And if I've got numbers in both of those things, x is going to, or sorry, k is going to be a specific number or fraction. Okay? Or decimal. Any issues, questions, comments about how to solve for k? You basically are just isolating k, nothing special here. This is not math that you've not done before, right? You want to see an example with numbers?
Yeah, well, if x is negative, but you multiply by negative, like, okay.
I would divide by a negative number. Right? So if they told me, you know, y was, let's see, y equals 10 and x equals 4. Can I solve for k? How do I set that up? Okay, and then what are you going to do? By? On? Okay. Okay. So 4's cancel out here. What's 10 divided by 4? Or 5 halves, right? So k equals 5 halves or 2.5. Is that right? Okay. So they may at that point, once I know that k is 2.5, they might plug in something. I would rewrite this equation as y equals 2.5x. Now that I know what the constant is, right, I could plug in anything I want for x and find out what y is going to be. Okay? Questions? Have I lost anybody here? Everybody feels pretty good. Okay, great. Let's see if there's anything else down here. Another way to decide if a relationship is a direct variation is to check whether the ratio is y over x. Okay? To see, does that happen? Okay? And we want to see if it's the same for each ordered pair, except where x equals 0. All right, so we might be looking at a graph. We want to see, am I getting that same ratio? Am I getting 5 over 2? Like, because they might give me a set of data, right? They may show me a whole bunch of x's and a whole bunch of y's. I would want to see, does y divided by x equal does it equal 2.5 every time? And that's going to tell me it's direct variation because the constant remains the same. Because if the constant isn't constant, then it's not direct variation. Does this make sense? All right, I don't know, let's see, do they give? All right, let me go ahead and give you an example of what I'm talking about. Okay, let's say they give me a chain of x's and y's What did we say? We said that what y was 10 and x was 4, correct? All right, so we've got 10 and 4 here. We've got 5 and 2 here. We've got, let's say, 20 and 8, 40 and 16, and then let's say 80 and 30. Okay, is this direct variation? Okay, let's check. What is 10 divided by 4? Is that 5 halves? Okay, 5 halves. 5 divided by 2. Is that 5 halves? Okay, works. What about 20 divided by 8? Is that 5 halves? Yep. Okay, what about 40 divided by 16? Is that 5 halves? Okay, 5 halves. Okay, so if we stopped right here, it looks like direct variation, right? Because all the constants are constant. They're all equaling the same thing. Is 80 divided by 30, is that 5 halves? No. Okay, what is 80 divided by 30? Right, that would be 8/3, right? So that's 8/3. If just one of the sets of data is non-constant with the other sets, it's not direct variation. Okay, if just one of them is not what the others are. Okay, does that make sense? If all of them track and all of them have the same constant, then we say, in this case, because we're doing y over x, okay, if y over x is the same for everything, then we say it's direct. Okay, if it has the same ratio all the way through. Do we follow that? Okay, so to write an equation for a direct variation, one point other than the origin that that likes on the graph, whatever, of the equation is needed. So we can't use 0, 0 because we'd have a divide by 0 problem there. We first find the constant of variation, k, and then we use the value of k to write the equation. So we're going to solve for k first. Okay. Does that make sense for everybody? Okay. All right. So they're going to start, what they're saying is they're going to start off by giving us numbers for x and y. We're going to use those to solve for k. Once we've solved for k, we're going to plug k back into the equation. Okay. In this case, we would say y equals 5 halves x because we solved for k. K was 5 halves. If we eliminate this from our set of data and we just go off of these, right, just acting like, you know, let's say that this didn't exist at all, okay, then this would be our equation, okay? All right. All right, lesson 57, finding least common multiples. Are we somewhat familiar with least common multiples? Somewhat review here, right? So it's the least number that is evenly divisible by each of the numbers in a set of numbers. It's what we call the least common multiple, or LCM. So we would write each number as the product of prime factors. Okay, so we take a number, we break it down into its prime. Step 2, we would use every factor of the given numbers as a factor of the least common multiple. We use each factor the greatest number of times that it is a factor of any of the numbers or expressions. So if we have multiple 2's in each set, so let's see if we can find the least common multiple. Somebody give me like a fairly large even number, like 256, right? So let's say, you know, give me a number kind of like 256. Doesn't have to be a 3-digit number, but let's try to do a 2-digit number that, let's say it's even.
65. 66.
Okay, 66. All right, let's break it down. Let's see, what's 256 divided by 2? Is that what, 126? 128, sorry, 128. Break that down into 2's. 54, 64. All right, 2 and what, 32? Okay, let's see, we got 32. We do what, 2 and 16, 2 and 8, 2 and 4, 2, and 2, right? Okay, so just so that we're seeing this, this is 1, 2, 3, 4, 5, 6, 7 2s, right? Breaks down into 7 2s, right? 66, that would be what, 2 and 33? Does it stop right there? I mean, we divide it by 3, we'd get what, 3 and 11, right? So what's the least common multiple? Is this how we do it? These are greatest common factors, right? So the greatest common factor that goes into both of them is 2, but is that least common multiple? No. Okay, so write each number as a product of prime factors. So the difference between what we just did and what we need to do is, let's say we have 256 and 66, writing them as factors of something bigger, right? So that would be taking, like 256 times 1 is 256, right? Here, 66 times 1 is 66. What's 66 times 2? What is it? Here, let's go with something a little bit smaller. Let's say we had something like, we want to find the least common multiple of 3 and 4. Okay, well 3 times 1 is 3, 6, 9, 12, right? Here we're getting, what, 4, 8, 12. What's the smallest number both of them will go into? 12. So 12 should be the least common multiple. Okay. Does that make a little bit more sense? So we understand the difference between greatest common factor and least common multiple. Okay. Okay. I know the bell's about to ring. I'm going to try to, well, there it is. So we will pick up. You guys do have the notes, right? So you guys can go through there. Can you go ahead and get started at least on hopefully 56 and part of 57? Okay. We're not grading those tomorrow, but hopefully I just want you to take a balanced approach to it. I don't want you to try to do 32 questions Tuesday night to turn them all in on Wednesday. Does that make sense? Okay. We'll see you guys. Have a great day.